The circuit that's being set up here is an 8 LED with the 74HC595 register. And what that's going to do is that when it is clocked, is that it's going to load a logic 1 out to each one of these LEDs. And it goes low and it'll reset, and the clock will cause us to shift along to each one of these LEDs on the output of that device. Taking a look at the program, we see that one of the variables we could change in here is this integer set up as the time delay, or T delay. Right now it's set up for 100 milliseconds, but we can change that to a longer time for delay, and we'll take a look in a minute to see what that is. Going through the program itself, you'll see that there's a latch on the IC chip, and the output of the board is pin 11. Is what's going to activate that latch for a certain period of time. If we go down to the next one, it's going to clock through the IC and cause it to shift into its shift register, which is on the inside of the IC chip. That's the control pin, pin 9, and pin 12 is going to be feeding into the data input to this register. So as we look at all these variables that are being declared at the beginning of the program itself is going to rely on this information before it can do anything in the program itself. Once everything's been reset through the void command, you'll see that each one of these outputs are going to control whichever one of these pins we declared earlier. For example, the digital write is simply going to be timed 1s and 0s, as opposed to an analog, which is more of a pulse width modulated output for its simulated analog signal. So here we have a digital write. It's going to go out. It's going to control the latch pin, which was declared up here at pin 11. The next thing it's going to do is it's going to shift out more information, and that is going to be the data being fed to the pin that's going to control what's going to be going out onto the LEDs, which is a logic 1. The digital write is then going to switch into the latch pin. The latch pin itself is controlling which of the LEDs are going to be going on that latch pin. Going into the next subroutine, you see right here, things are reset. Back to pin modes, and here on the latch pin, the data pin, the clock pin is the output, and that's what's going to control the IC chip and going to determine what comes out of the IC chip. On the third loop that we have down here, and you'll notice more from setup to a loop, the LEDs initially start out at 0, and then they're going to update on the shift register. This particular part here is relying on the subroutine, first part of the program, which were declared in this part of the right here. Going back down, we have to see the delay. The delay was determined up here, and it was set originally at 100 milliseconds. So if I change this part here, it's going to change how fast this is going down here. After it updates the shift register, it's now going to go in and it's going to cause the delay, which was this declared up here, and it's going to loop back around. This allows for the IC chip to increment. That's this part right here between pin 0 and 8. This 1 plus right here is allowing it to increment every time that this loops around. So I'll start out pin 1 to pin 2 and go all the way up to pin 8. So taking a look at the circuit itself, we can see that the three signals, which are right here for the latch, the clock, and the data, are coming out of the microcontroller board here. As it goes through the IC chip, which is the 74HC595, its outputs are driving each one of these LEDs to a logic 1, which is going to indicate its operation. Once it's already set to logic 1, it goes to the next one. The latch then latches in a logic 1 and turns this light on. Incrementing, which was part of the program, will go to the successive lights and go all the way out. Once it hits to 8, it recycles back and goes back to 1. Very interesting way of taking a look at serial in data and watching it go to a parallel output.